Okay, today is our introduction to matrices. Specifically, we're going to talk about augmented matrices, which is something that I think should be new to about everyone here. And if this is your first introduction to matrices, I'm not going to lie, it is a little bit complicated, although it does kind of relate to what we do with elimination. With that in mind, know that this is like the hardest part of matrices. So it should get easier from here. About the next 4 lessons all have to do with matrices, so just keep that in mind. Don't get too discouraged, okay? So today we are going to work with matrices, and there's a couple of key things that we're going to do. First of all, when we're working with a matrix and we're kind of changing rows up, we can interchange the position, so interchange like where the spot of 2 rows are. We can replace an equation with a non-zero multiple of itself, so we can multiply something. And then we can replace an equation with itself plus a multiple of another equation. So we can also add rows. So kind of our 3 things today is we can swap rows, we can multiply rows, and we can add rows. Okay. So when we talk about what a matrix actually is, it's a rectangular array of numbers enclosed with square brackets. We're going to use it to write our system as a matrix. We include only the coefficients and constants, so we're not going to have any variables in our matrix. An augmented matrix has the coefficients along with a column of constants. Okay. For today, we're going to recognize something called row echelon form. So a matrix holds true for the following conditions. The first non-zero entry in each row is a 1. So they're saying, hey, this is going to be a 1. So you got a 0, so that's okay, but then this is going to be a 1. So it's referred to as the leading one. The leading one of any given row must be to the right of the leading row of above it. So notice how this is first, and then this second one here is to the right of it. So notice if you look at like these squares, they're going to the right of where the following one was. And then any row of zeros cannot be placed above rows of non-zeros. So the zeros are at the bottom. Okay. Reduced row echelon form is that same exact thing, so that row echelon form, but ones are the only non-zero entry in the respective column. So notice here you've got a 1, and then you've got all zeros. When you've got a 1, you've got a 0 above it and 0 below it. When you've got a 1, you got zeros above and below. Whereas down here, up top, there could be a number above the ones. So let's first let's just talk about what it means to have this matrix and what the system is. So, in general, this first column will be your x's, your y's, and then these are your answers. So if we wanted to think about this as a system of equations, this is saying like 1x plus 0y equals negative 2. Or in other words, x equals negative 2. This next one's saying 0x plus 1y equals 7. Or in other words, y equals 7. So those are the solutions, right here, to your system of equations. Okay, this one, now that it has 3 columns, we're going to have x, a y, and a z column. These over here on the right are always going to be the answers to the constants. So you're going to have 1x. If you don't have any zeros you have 0 y's and 0 z's, it's really just x equals negative 3. You've got y equals 20, and z equals 19. Okay. On this next one, sorry, I should have left a little bit more room, that's okay. We've got 1x, so x, y, and z, plus 9z equals negative 3. Then we've got 1y minus 4z equals 20. So it almost looks like a system we're going to solve. But let's look at this last row. This is kind of what you're going to focus on with these ones when you don't have just like the ones down the diagonal. If you have 0 equals -1, that is not a true statement. So this part right down here implies that there is no solution. Meaning, hey, this system is inconsistent. So if you just look at that last one, usually remember to think about when you solve a system, if you get 0 equals 1, right? That's not a true statement. Doesn't work. Okay, so let's look at this next one, x, y, z. Notice we got a similar thing. We've got this 1, we got the 1, but then we also have these numbers here. So let's look at this bottom row. This bottom row says 0 equals 0. When you get something like that in a system, that really means that there's infinite solutions. So this first equation says x plus 9z equals -3, and y minus 4z equals 20. So if we wanted to say, hey, I mean, infinite solutions is technically the answer, but sometimes they say, hey, these infinite solutions all take the form of. So we'll say, maybe we'll say like, put answer in terms of z. It means we want like to set x and y equal to what z in terms of z. So if we look at this top equation, I could subtract 9z on both sides, and I'd have x equals -3 minus 9z. Then on this one, I could add 4z to both sides, and I'd have y equals 20 plus 4z. So if you wanted to think about this, your x is -3 minus 9z. Your y is 20 plus 4z, and then you just have z. So if you write it in like that ordered triple like we do sometimes, you'd have like -3 minus 9z, 20 plus 4z, and then just z. So like if you plugged in the number 1 as an example, like so if z equals 1, then you would have something of the form of -12, 24, and then 1, right? And if z equals 2, you could then plug 2 into z for everything, and you could see what it would look like. Okay, and this is a little example. So now let's look and kind of recognize, hey, are things in reduced row echelon form? So, as we take a look at this, the fact that it looks like the identity on the left is reduced row echelon form. Meaning, hey, there's ones, and if there's a 1 in a column, there's only zeros above or below it. This next one, while we do have some ones, notice there's like multiple there. They're not zeros everywhere else. They're not just doing it to the right of the one previously, so this is neither. Okay. Sorry, there should be a line here. These are kind of your answers. So now let's look at this. We got 1, and we've got a 1. So it's kind of looking at the identity. That's good for reduced row echelon form. And then we've got zeros above and below wherever the ones are. So this is reduced row echelon form. This last one has all zeros, and that's also okay with reduced row echelon form. It just basically means, hey, it's at either infinite or no solution. Okay, this last one, I've got my 1, so that's a good sign, but notice how there's a 2 there? That just means it's row echelon form. So it tells us something about it, but that should be 0. Oops, sorry. Should be 0 for reduced row echelon form, and when it's in this reduced row echelon form, then it's going to give us our answers really nicely. And that's going to be the whole idea behind what we're doing today, is we're trying to get things into reduced row echelon form. So solve the system of linear equations using matrices and elementary row operations, interchanging any 2 rows, multiplying a row, and adding 2 rows. Be careful never to lose a row. Let's see what it looks like. So the way we're going to set this up is we're going to put the coefficients here for x and y, right? And then you're going to have the answers over here on the right. So here we'll have -5, 1, and then a 17. Then we'll have 1, 1, and then 5. The whole idea behind it is we're trying to get the left side into reduced row echelon form. You can think about that basically as trying to make the identity matrix, so making those ones along the diagonal on the left. Okay, it is up to you how you want to do it, but I usually start and I'm like, okay, I usually look at a column or I look to see where there are some ones. So like, let's say I focus on this one right here. Usually, if you think about the identity, right, like 0, 1, 0, 0, 1, that's the identity. That's kind of the format you're trying to get it into, or as close to that as possible. It's occasionally where the bottom row is like zeros. So what we're going to do there is I'm going to just swap. So I'm going to interchange row 1 and row 2. So I'm going to put it in the upper left corner, so it's kind of what we're used to. So if I do that, then I'm going to have 1, 1, 5 on the top. I'm going to have -1, 5, 17 on the bottom. Okay, so then I usually go down to the column. So I'm like, okay, this one's good now, but I want to make this a 0. So think about what you would do with elimination. If you're trying to get rid of that -5x, what do? We do 5 times the first row, and if we add it to the second row, a +5 and a -5 will cancel. So if I do that, I'm going to kind of do 2 steps here. So I'm doing, I guess I want to put it a little bit lower here. So this, I guess it's okay. Actually, I'm going to put it a little lower. So I'm going to place it. The top row is not going to change at all. This 1, 1, 5 isn't going to change. So I'm going to now place what we were just talking about doing that 5 times row 1 and adding it to row 2 down here, because we're going to change row 2, right? We're trying to make the second row a 0. So I'm going to do 5 times 1, which is 5 times the top row, plus -5, which is the bottom row. I'm going to do 5 times 1, which is the top row, plus the bottom row, which is 1. I'm going to do 5 times 5, which is the top row, plus the bottom row of 17. So this is really equivalent to top row hasn't changed at all. And on the bottom row, I now have 0. And then I've got 6. And 5 times 5 is 25, plus 17 is 42. Okay. So we now want to go ahead and we want to make that bottom row. Let's talk about it in blue. I've got this is good, this is good. I now look at this second column and I'm like, hey, this has to be a 1. I usually deal with the zeros at the end, so we're trying to make that 6 a 1. So I need to do 1/6 of row 2. And the reason why I'm writing it as 1/6, you really can think about it as dividing, but we can only technically multiply here in this matrix. So 0 times the 6 is still 0, but I'm going to do 1/6 times 6 and 1/6 times 42. Okay, so the top row hasn't changed at all, 1, 1, 5, and then I have 0, 1, 7. Okay, so now the only thing I have left is above this 1, I want to make this a 0. The way I'm going to do that is I'm going to take the bottom row, I'm going to multiply row 2 by a -1 and add it to row 1. Because then you'll have -1 plus 1 is 0. So 1 plus 0 is still going to give you 1 there, but you're going to have -1 times 1 plus 1, and then you're going to have -1 times 7 plus 5, and then the bottom row hasn't changed at all. So I get 1. -1 times 1 is -1 plus 1 is +1, so plus +1 is 0. 0, 1, and then on the right here, -1 times 7 is -7 plus 5 is -2, and then 7. So from that, you get your solution here, right? Like we read above. Remember, this is x, and this is y. So you have 1x equals -2, and you've got 1y equals 7. Okay. Let's now look at this next one. Okay, so same idea. We're going to start it off and we're going to do 3, 4, and then 12 is your answer, -6, -8, -24. So remember, this is like your x, your y's, and then your answers, right? Your constants. Okay, this one's a little trickier. We want to try to get it like the identity. So choose one column to focus on. So maybe I try to focus on this first column, let's say. And what I really want this to be is I want this to be a 1, right? And I want this to be a 0. In this case, I mean, you could start dividing by that first row by 3, or sorry, times it by a 1/3 to get it to 1. But I think it's going to be easier to make that a 0, and then we'll worry about making that a 1. So, in order to make this bottom row a 0, right, that -6 is 0, I'm going to do 2 times row 1 and add it to row 2, right? Because 3 times 2 is 6, and 6 plus a -6 is 0. So if I do that, the top row hasn't changed at all, right? But 3 times 2, or sorry, I'll do 2 times 3 plus a -6, 2 times 4 plus a -8, 2 times 12 plus a -24. And we get that this is now 3, 4, 12, 6 plus a -6 is 0. 2 times 4 is 8 plus a -8 is also 0. 2 times 12 is 24 plus a -24 is also 0. Okay, to technically make this in row echelon form though, right, I've got to do one more step. I've got to make this a 1. So the way I'm going to do that is do 1/3 times row 1. So now I've got 1, I've got 4/3, and 12 times a third is 4. And I still got my zeros on the bottom. This is now in that reduced row echelon form. So what you'll notice at the bottom here though is you've got 0 equals 0. Remember, what does that imply? That implies that there's infinite solutions. So infinite solutions would be the answer here, but if they ask you, sometimes they say like, put in terms of y, let's say. Technically this top equation, if we go up here, is there's 1x plus 4/3 y equals 4. So if you wanted to solve x for y, you do 4, and the opposite of positive 4/3 is a negative 4/3 y. So technically we could write this as the 4 minus 4/3 y, comma y would be like the format of what all your answers would be in. Okay. These next ones become a little bit more difficult because there's now 3 variables, but the same idea is going to apply. You're trying to make the left side get into that reduced row echelon form, but you can kind of think about it as like making the identity on the left. So remember, we're going to have our x's, our y, and our z's, and then our answers, right? So 4, -1, 1, 5, 2, 0, 6, 30, 1, 0, 1, 5. Okay, so I usually focus on one column. In this case, I think that middle column looks super nice, right? Because it's exactly how I want it to be. There's 2 zeros and there's almost a 1. The only thing that I need to do is multiply that first row by a -1, and then it'll be in the exact format for the middle column to be all set. So I'd have then a -4, a +1, a -1, a -5, and the second and the third rows have not changed at all. Okay, this middle column's looking pretty good. The only difference is we want, technically, like if you think about the identity, 1, 0, 0, 0, 1, 0, 0, 0, 1, is we want that to be in the middle. You can either worry about it now or you can worry about it at the end. I'm going to swap, though, row 1 and row 2 right now. Actually, I'm going to be a little smarter. I'm going to wait a second, and I'm going to maybe decide to swap over let's swap row 1 and row 2. That's fine. So here, as you may kind of notice as I took a pause there's multiple different ways to like solve this. So I'm walking through one way, but there are other correct like steps you could take. Like you could switch this later and you'd still get the same result. Make sure though as you swap a row, you also swap the answers, right? Okay, so this middle column is how we want it to look. 1, 0, 1, 0. The next thing we want is to either focus on the last or the first row. I'm going to focus on this last row because this one right here is in the spot that we want it in. So that's where we want it. We want to make this -1 and this 6 both zeros. So let's talk about how to do that. In this case, I usually almost always take where the 1 is. Particularly, you want to be careful here. Like if you took the second row and multiplied it and added it to the first row, you'd get rid of that 0 that you already made in the middle, right? Because you'd do like 1 times something and you'd add it to 0 and it would change that. So make sure we're going to take the bottom row and multiply it by something and add it to the other rows. So to get rid of this 6 in the top row, we're going to take that bottom row and multiply it times a -6, and we're going to add it to the top row. So let's go ahead and pause and do that. This time I don't think I'm going to write out that middle step, but we're going to just talk about it. So -6 times 1 is -6 plus 2 is a -4. -6 times 0 is still 0, plus 0 is still 0. -6 times 1 is -6 plus 6 is 0. -6 times 5 is -30 plus 30 is also 0. Okay. I'm going to also get rid of the 0 in that second row. So I'm going to take row 2 and add it to row 3 because a -1 plus a +1 is 0. So 1 plus -4 is -3. 0 plus 1 is 1. 1 plus -1 is 0. 5 plus -5 is also 0. The bottom row has not changed. So you'll notice now this whole first row second column and third column are what we want it to be. We now want to make this a 1, and then we'll want these to both be zeros. Let's focus on just making that top row a 1. In order to make that top row a 1, I'm going to need to multiply by -1/4. Or you can think about it as dividing by -4, but remember we don't divide, so we are multiplying by that fraction. So we get 1, 0, 0, 0, and then I have not changed these other two rows. Okay, so now we're going to go ahead and we're going to make this first column all set up. We're going to make these both zeros. So the way we do that is we're going to take that first row, and you want to take the first row such that you won't change the other ones that we've already made. And we're going to do 3 times row 1 and add it to row 2. And we're going to do, because a +3 plus a -3 cancels. We're going to do -1 times row 1 plus row 2. Okay. So top row hasn't changed, but 3 times 1 is 3 plus 3 is 0. 3 times 0 is 0 plus 1 is 1. 3 times 0 plus 0 is still 0. 3 times 0 plus 0 is still 0. -1 times 1 is -1 plus 1 is 0. -1 times 0 is 0 plus 0. -1 times 0 is 0 plus 1 is 1. -1 times 0 plus 0 plus 5 is still 5. So we now have our answers here, right? This first one represents that x equals 0. Y also equals 0 is that second row. And the third row tells us that z equals 5. Okay. Let's try another one together here. Okay. So on this next one, once again, we want to start off and we want to write the coefficients of the variables. So we're going to have 2, -3, 1, and then a -1, 4, -4, 4, and a -13, 6, -5, 7, and a -25. Okay, for the record, I know some other teachers will always be like, okay, since we want it to look like the identity, like let's make this first one a 1 and just go from there. But I always like to make life easiest. So you could kind of focus on this one and kind of go backwards. However, today, maybe I will focus on this first column to begin with, because none of these columns are, actually, no, we can do that. We'll start with this one, like we would. Okay, so if I want that to be a 1, I want these to be zeros. So I'm going to multiply -4 times row 1 and add it to row 2. And I'm going to do -7 times row and add it to row 3, and I'll get that last row to kind of look like what I want it to. So if I do that, the top row has not changed at all. And then I'd have 2 times -4 is -8, plus 4 is -4. -4 times -3 is 12, plus -4 is 8. -4 times 1 is -4 plus 4 is 0. -4 times the -1 is +4 plus -13 is -9. Okay, then I do it to the bottom row. So I do -7 times 2 is -14 plus 8 is plus 6 is -8. -7 times -3 is 21. Plus a -5 is 16, and I get 0. This last one, I get -7 times -1 is a +7, plus a -25 is -18. Okay, so that last row is how we want it. I now would choose one of these other ones. I like to do like smaller numbers, so maybe I do like this first one. And I'm going to try to make that a 1, so then these will be zeros. Okay. In this case, it's up to you. You can make it a 1 right now, which actually isn't too bad, because if I multiply that middle row by -1/4, I would get a +2, and that's still an integer, just the answer that's a fraction, so that might not be a bad idea. So let's try that. Let's see what we get. Yes, we will get some fractions. So I haven't changed the first or the last row at all. But here, if I change this middle row, I end up with a 1, and then a -2, a 0, and then +9/4. Okay, now that I've done that, remember in this first row, I'm going to make these other two numbers a 0. So I'm going to do -2 times row 2 plus row 1, and I'm going to do +8 times row 2 plus row 3. Okay, so -2 times 1 is -2 plus 2 is 0. -2 times 2, -2 is 4, plus -3 is 1. -2 times 0 plus 1 is still 0. This one, be a little careful with your fractions. 9/4 times -2 plus a -1. Okay, so let's see. -9/4 times -2 is going to give you a -9/2. But then when you add another -1, which you can really make -2 or -2, that's going to be -11/2. Okay? And then this middle row hasn't changed at all. And then this bottom row, when I do 8 times that, I'm going to get 8 plus negative 8 is 0. And negative 2 times 8 is negative 16 plus 16 is also 0. Then we'll also have 0 plus 0. And when I do 9/4 times 8, I should get 18 plus 0 is 0. So notice in that bottom row, I have all zeros, which that should tell you something right away. We know that that is infinite solutions. At this stage, the only thing I'm going to do is just a formatting things. Usually, right, this 1 comes in the upper left-hand corner, so I'm going to switch row 1 and row 2. The one that has all zeros will stay in the bottom row, but this is 1, negative 2, 0, 9/4, 0, 1, 1, negative 11 halves, and then 0, 0, 0. And the fact that 0 equals 0 here implies that there are infinite solutions. It may be enough just to leave it in that format of saying infinite solutions, but if it does ask you to put things in terms of a variable, in this case, our first equation would be x minus 2y equals 9/4. And then we'd have y plus z equals negative 11 halves. So something like this, they probably would ask you to put it in terms of y, maybe? So they'd say like, hey, this is x equals 9/4 plus 2y, and y equals negative 11 halves minus z. Okay? So, and then you just have y as your other variable. Oh, sorry, I put that in terms of z. That should be the other way around. Let's make z equal in terms of y. Z equals negative 11 halves minus y. And then you'd have y as just the other variable. Okay. Let's look at 2 more examples here. Okay, so we know how we get started. We put the coefficients in our matrix along with the answers. Okay. In this case, you got kind of 2 options here. I may actually start off, I'm like, hey, this first row doesn't look too bad, and you may actually like make that kind of the 1. Or otherwise, I may focus on the 1 over here and just be like, hey, let's leave that 1 and let's see if we can make things work out for us. So let's make these 2 0. I usually like to focus on the ones I just feel like it's easiest and try to kind of get it in that identity, and then things fall into place. So I'm going to do negative 5 times row 1 and add that to row 2 to have it cancel out with the 5, and negative 3 times row 1 plus row 3 to have it cancel out with the 3. So the top row hasn't changed at all to negative 1, 1, negative 1. But now negative 5 times 2 is negative 10 plus 4 is negative 6. Negative 5 times negative 1 is 5 plus 3 is 8. Negative 5 times 1 is negative 5 plus 5 is 0. Negative 5 times negative 1 is positive 5 plus 1 is 6. Okay. Now we've got negative 3 times 2 is negative 6 plus 0 is negative 6. Negative 3 times negative 1 is positive 3 plus 5 is 8. Negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times negative 1 is 3 plus 4 is 7. At this stage, you may kind of notice something about the 2 equations. If you just look at those bottom 2 equations, they look almost identical with the exception of 1's equal to 6 and 1 equals to 7. So if you have 2 equations that have different answers in their system, that should kind of say something to you. But if you haven't picked up on it yet, stay tuned and we'll keep going on. At this stage, this whole last row is good to go. But I may just kind of recognize, hey, the second and third rows are multiples of each other. So if I do -1 times row 2, I'm just going to add it to row 3 and kind of see what happens. And things should kind of become zeros, and we like zeros here. So I've got 2, -1, 1, -1, -6, 8, 0, 6. And then I'd have 0, 0, 0, and I'd have a +1. We're not quite in the reduced row echelon form like we want it to be, but technically this last row tells you something just right now. 0 cannot equal 1. So that means that there's no solution right there. It's inconsistent. But if we wanted to continue to get it into the form that we want it in, we want to make this first one as a 1 first. Actually, yeah, I can do that. So we're going to do 1/2 times row 1. So 1/2 times row 1. And then I'm actually going to make it cancel out with the one below it. And I'm going to do 3 times row 1 added to row 2. I'm going to do 2 steps at once here. Okay, so this would be 1, -1/2, and 1/2. And then -1/2. And then if I look back at what we had, 2 times 3 is 3, plus a -6 is 0. Sorry, and a -1 times 3 is -3, plus 8 is 5. 3 times 1 is 3, plus 0 is 3. 3 times -1 is -3, plus 6 is -3. The bottom row still has not changed. Okay. One more step that we have to do would technically be to make this 5 a 1. So I'm going to do 1/5 times row 2. And you'd have 1, -1/2, +1/2, -1/2, 0, 1, 3/5, 3/5, and then 0, 0, 0, 1. Since at the end, though, 0 cannot equal 1, we know that this is no solution, meaning this is an inconsistent system. Okay, one last one. If you're feeling pretty good and you want to try it on your own, the ending answer should be that x equals -3, y equals 1/2, and z equals 1. However, if you want to kind of follow along, we'll do one more together. Okay. So we got our coefficients here. And we've got our answers on the other side. Okay. I'm going to start with the first column this time. So I'm going to make this a 1, and I want to make these both zeros. So I'm going to do -2 times row 2 and add it to row 1. And I'm just going to add row 2 and row 3 and put that in row 3. Okay. So I get 0. -2 times -2 is a +4, plus -4 is 0. And -2 times +2 is -4, plus 1 is a -3. -2 times a -2 is +4, plus -7 is -3 as well. And then I have not changed the second row at all. And the bottom row, and I add those together, I get 0. -2 plus 4 is 2. 2 plus -2 is 0, and I get 1. Okay. I'm going to do a little rearranging. So this is technically my 1. This last row looks like it's going to be kind of like that middle one that we keep, and then this top row looks like we're going to be the last one. So I'm just going to switch some rows around. I'm going to switch. I'm going to put row 2 up top. I'm going to put row 1 on the bottom, and I'm going to put row 3 in the middle. So we're just kind of switching the rows. Switch. So now we've got 1, -2, 2, -2, 0, 2, 0. And then this is 1, sorry. 0, 0, -3, -3. Okay. So now, let's go ahead and I'm going to focus. I've got this whole row done. I want to make that a 1 and same with this. So if I make those two 1s, I'm going to do 1/2 of row 2 and negative 1/3 of row 3. And notice, yes, I'm now calling, these are now new row 2, new row 3s. Okay, so we have not changed the first row at all. And now I get 0, 1, 0, 1/2, 0, 0, 1, and then 1 as well. Okay, so the only thing left for us to do is make these zeros up top, right? And if those are zeros, it's exactly in our identity format, our reduced row echelon form in this case, and we'll know what X, Y, and Z are. So I am going to do 2 times row 2 and add it to row 1. And I'm also going to do negative 2. I'm also going to add to that plus a negative 2 times row 3. Because then I'll have to get both those to cancels. Double task in here. Okay. So if I go through and add the second row, twice the second row, I get 1, and then I get 0. I'd still have 2, and then I'd have negative 2 plus 1. Okay, let's go through and add negative 2 times the third row. So I'd still get plus 0 here, that's not going to make a difference. And I get plus 0 here, that's not going to make a difference. But then I would get a negative 2 there. And I'd get minus 2 over here on the left. We didn't change the second or the third row at all. So one last step, let's just simplify this. So we get 1, 0, 0, 0, 1, 0, 0, 0, 1. And when I do negative 2 plus 1 plus negative 2, we get negative 3, 1/2, and 1. So just like I said at the beginning, this first row tells us that X equals negative 3, Y equals 1/2, and Z equals 1. Okay, the nice thing about this homework is there isn't a ton of questions, but be aware it does take a while to do each question.